Hello chemistry students, this is the final lesson in Unit 9 where we're going to take a look at percent yield. So the goals for this unit, or for this lesson, would be to define the actual yield and the theoretical yield for a reaction, and then to calculate the percent yield for a reaction given the starting amounts of reactants and the amount of product collected. So let's get started with the lesson. Okay, so first off, let's define terms here. The actual yield of a reaction is the actual amount of product that you recovered from some chemical reaction. And we can express this in grams or moles, or we can even express it, I didn't add it on here, but it could also be expressed in liters if we collect a gas. Alright, so the theoretical yield would be the yield of some product that's predicted by the reaction stoichiometry. And again, that can be grams, moles, or of course, I'll add it on here, it could be liters as well. Alright, so the percent yield of a reaction is basically the actual amount of the product you get divided by the theoretical yield that the stoichiometry predicts multiplied by 100. So if you rule out any contamination from other substances, the percent yield theoretically could be no greater than 100%, and in actuality it's almost always less than 100%, because generally no chemical process, the lab work's never perfect. You're going to lose product, or you're going to have maybe some small amount of reactant that doesn't react for whatever reason, and so you don't always collect all of the product that the stoichiometry would have you do. So, ideally, if you're a chemical engineer, you want to maximize that amount so that you're not wasting chemicals, you're getting the most product that you can. So it's a useful tool to analyze your lab technique and figure out how much you actually got compared to what the math says you should get. So let's try an example problem. Alright, so let me walk you through this. I've taken some photos. So this photo right here is showing we have started with 2.04 grams of silver nitrate. We then took it down here, we dissolved that silver nitrate in water, and we suspended a piece of copper wire in the aqueous solution of silver nitrate and water. And of course, this is the lab that we did in class. And you know that you're going to have a single replacement reaction. All on that copper wire, we should be collecting silver as the copper and silver undergo that single replacement reaction. So on the right, what I've shown is we've massed an empty weigh boat. We've then collected the silver and dried it. So this is the silver precipitate collected in the reaction. And so the mass changed from 2.30 grams in the empty weigh boat to 3.17 grams. Alright, so let me move some of this out of the way and we'll see what's kind of important here. So first of all, we need our massive silver nitrate. That's going to be what we actually put in there. So that's going to calculate our theoretical yield. Okay, and then we need to subtract these two to find the amount of silver that we actually got. That would be our actual yield. Alright, so let's move this out of the way. So the actual mass collected here was, 0.87 grams of silver. So that's grams of Ag. So now, how are we going to get the theoretical yield of silver? Well, for that, we're going to need to go back here to our reactant, the silver nitrate. We're going to assume for this lab that this is the limiting reactant, so that we had an excess of copper, which makes sense because even after this reaction's over, there's still copper wire left. So let's move this out of the way. So we're going to use that mass, 2.04 grams of silver nitrate, to calculate our theoretical yield. Okay, we're going to calculate our theoretical yield. So we're going to find the theoretical mass of silver in this reaction. So here's our reaction. We have 2 moles of silver nitrate, react with a mole of copper. We get a mole of copper 2 nitrate in aqueous solution and 2 moles of silver. So it's a 2 to 2 molar ratio. So then you just do the math. Here's our limiting reactant, silver nitrate. There's the molar mass of silver nitrate, grams in a mole. It's a 2 to 2. And let me move this over. Okay. And then the molar mass of silver comes in at the end as 107.87. And so doing the math, which would be 2.04 divided by 169.87 times the fraction 2 over 2, which cancels itself out, multiplied by the 107.87 at the end, we're going to calculate a theoretical yield of 1.29 grams of silver. Okay, we actually collected 0.87 grams of silver. So substituting into our equation here then, got a lot going on this screen. Okay, our percent yield then is going to be the actual, which is the 0.87 grams of silver, divided by the theoretical. We could have gotten 1.29 grams of silver. Grams cancels out. We multiply it by 100. So my calculator is telling me that I'm getting 67% yield from this reaction. So maybe we didn't let the copper wire in there long enough to react with all the silver, or for some other reason the reaction kind of stalled out and we didn't get all of the silver out, so some of those silver ions are still hanging around in the solution. We got about 2/3 of it in that reaction. Alright, let's go on and I'll give you one more problem to try for a post-video question. Okay, so our post-video question deals with the decomposition of sodium bicarbonate. And the given amount is that we're saying we've collected 1.10 liters of carbon dioxide gas, and we'll say that it's at standard temperature and pressure. Here's the reaction. So you take sodium bicarbonate and you heat it, so I need a little delta symbol. We apply heat and it decomposes into 3 products. Carbon dioxide gas, which is going to bubble off and you can collect it, water, and then solid sodium carbonate, which actually would probably remain dissolved, so it would actually probably be an aqueous product. You can do this reaction with dry sodium bicarbonate and heat it over a Bunsen burner. You can also do it in the liquid and heat the water up to boiling. The process is going to be the same. You're going to get the same 3 products either way. Okay, so what we're saying is we started with 10 grams of sodium bicarbonate. So we have 10 grams of this reactant. Okay, and we actually collected 1.10 liters. So that's our actual yield. So this is going to be kind of a 2-step process here. The first thing you're going to have to do is find theoretical yield of carbon dioxide. So you're going to need to do a problem to work that out. That's a stoichiometry problem. And then secondly, you're going to do the calculation to determine the percent yield. So give that a try and we'll discuss it next time in class. Good luck.